Hey guys, welcome to Unit 7, Lesson 4. Our topic today is trigonometric derivatives. So I want you to pause the video and try the warm-up. The warm-up says graph the derivative for each of the functions whose graphs are shown below by analyzing the slope of the curve at various points. So anytime you are graphing the derivative of a given function, you can think of derivative as the slope of the tangent line. So wherever you look for your maximums and minimums, right? So wherever you have the maximum and minimum, you know your slope of the tangent line is going to be 0. So your m is 0 here. So I can simultaneously plot that's pi over 2. I have a 0 at pi over 2 and 3 pi over 2. I will have zeros. So now over here at 0, look here, the slope looks like it's very close to 1, so it is 1. And this whole part, it's positive slope, so it's going to be above the x-axis. Here the slope is negative from this point to this point, so it's going to be negative slope, so it'll be below the x-axis. And here my slope looks like it's negative 1. My slope is negative 1. And here again, my slope looks like it's positive 1 and it is increasing. So I'm going to fluctuate between what? 1 and negative 1? Oh, here. So I'm going to call this 1. This is negative 1. So at 0, I'm at 1. And then at pi over 2, I'm 0. That we already marked. And then at pi, we had negative 1. So that's my lowest point. 3 pi over 2, we already said it's 0. And at 2 pi, I'm again at 1. So I'm going to connect these dots. And what do I get? Do these functions look similar? Do these graphs look familiar to you? This starts at the 0 and it ends at 2 pi. This is y equals sine x. And you just graphed its derivative, which looks like what? Your cosine function. So the derivative of sine x is cosine x. Same thing. Now what does this graph looks like? This looks like a cosine function, right? So again, look for your maximums. So wherever you have a maximum or a minimum, your slope of the tangent line is what? 0. So that was a maximum. Here it's a minimum. Your slope is what? 0. And again, you have another maximum. It's 0. So now if you look at from this point, this is what? Decreasing. So your slope is, or your graph is going to be below the x-axis. And here, your slope is what? Negative 1. Here it looks like it is going up. So it is, slope is 1. So again, we're going to be fluctuating between 1 and negative 1. I'm going to scale my axis. So negative 1, 1. So at 0, I have 0. My value is 0. I'm going to do it in a different color. So it makes, this is 0. And then at halfway between pi is pi over 2, I'm at negative 1. Then I am again at 0 because my slope of the tangent line was 0 at pi. Then I'm at 1. Right? My slope is 1. We're talking about we're graphing basically the slopes. And at 2 pi, my slope is again 0. So if I was to sketch it, what does it look like? It is similar to the sine curve. Actually, it's a reflection of the sine curve over the x-axis. So this is my y equals cosine x function. So the derivative of my cosine function is y equals negative sine x because it's going down instead of going up. Your original sine function is up above also. I'll just sketch it here in red so you kind of get an idea. That's what your sine function is. So it's a reflection over the x-axis as you can see it, and that is why it's a negative sine function, a negative sine x. So using the graphs above, we now know that the derivative of sine x is cosine x, and derivative of cosine is negative sine x, and we just showed it on the graph. So for the next page, it says the derivatives of the 6 trigonometric functions have to be memorized since they are used very often. So please make sure we get very, very comfortable with them. You don't need to know how to derive them, but you need to just have them memorized. So it says we can find the derivative of tangent x by using the derivative sine, cosine, and the quotient rule. So we're going to just derive one of them. So let's see. So tangent x, I'm going to find the derivative of this. Tangent x can be rewritten as sine x over cosine x. Do we agree? Going back to our unit circle. Now, use the quotient rule. This is my a, and that's my b. So what is the quotient rule? It's the derivative of the numerator. So derivative of sine x is cosine x times the denominator minus the numerator times the derivative of the denominator, which would be negative sine x. Right? We just saw that on the last page. Over the derivative, the denominator square. So that's what we got. If we simplify this, I get what? Cosine square x plus sine square x over, can I rewrite this also as cosine square x? Now, this is your identity, Pythagorean identity, right? So that would be what? Just 1 over cosine square x. 1 over cosine square is what? Secant square x. So derivative of tangent x is secant square x. You can derive the remaining of derivatives of the remaining trig functions can be determined in the same way. So we're not doing that, as I told you. I'm just going to give you the derivatives of each one of them. We already saw 3 of them. I'm going to give you the other 3. So we know the derivative of sine x is cosine x. Derivative of tangent x is secant square x. Derivative of secant x is, it's not tan x, please don't be, it's secant x times tangent x. The derivative of cosine x is negative sine x. The derivative of cotangent is negative cosecant square x. And the derivative of cosecant x is negative cosecant x cotangent x. I don't know if you noticed here, these functions that start with c, all my c functions are always going to be negative. So let's write that down. C's are always negative. The derivative of all the c's is always negative. That's what I mean. So that's one way of remembering it. But the other way would be just keep practicing them, write them. I would highly recommend writing all these derivatives on a piece of paper so that you have them in front of you. Okay, so let's get started with these questions. So as of now, we have done the power rule, the product rule, the quotient rule. So we might be applying all of those when we're working with these questions. So the first one, it says, find the derivative of this function. So again, I can do these separately. So what is the derivative of sine x? It is cosine x. And what's the derivative of x squared? 2x. So that's it. B. So be a little careful with B, because if you see here, there's x, there are 2 parts to it, right? So we're going to be applying the product rule here. I already wrote the product rule up here. The derivative of a times b is equal to a prime b plus ab prime. So we're going to do that here. So f prime of x is derivative of x is just, this is your a and this is your b. Cotangent x is your b. So derivative of x is 1. Cotangent x, I'm going to put this in parentheses, plus x times, what is the derivative of cotangent x? It is, remember, all the c functions are negative. So it's going to be negative cosecant square x. Plus, what's the derivative of 5x? Just 5. You can simplify this further. This would be what? Cotangent x minus x times cosecant square x plus 5. And that's your derivative. So I want you to finish the remaining problem set. Good luck.